بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 6.3, which is about volume using cylindrical shells. Let me remind you that there are two formulas here in this section. The first one, when we rotate about y-axis, in this case, it would be integral. The volume would be given by integral of. We will take a rectangle parallel to the y-axis. So the width of the rectangle would be dx, and the volume would be 2 pi x, which is the circumference of the cylindrical shell times f of x. And dx represents the width of the rectangle from A to B. X here is the radius of the shell, which is always the distance from the axis of rotation, which is here y-axis. So let us say from y-axis to the rectangle which we draw, which is here parallel to the y-axis. And f of x is the height of the rectangle. So this is the first formula. The second formula, if we rotate about x-axis, then we choose a rectangle parallel to the x-axis. The width of the rectangle in this case would be dy, delta y changes to dy, and 2 pi y is the circumference of the shell times f of y, the length of the shell in this case. Pi is the radius, and f of y is the length of the shell. So these are the two formulas here. So this is an exercise solid. We have this graph. Set up an integral using the method of cylindrical shells for the volume of this solid. We need to rotate about the y-axis. So we choose a rectangle parallel to the y-axis. The width of the rectangle is delta x. So the integral would be with respect to x. X runs from 0 to square root of pi over 2. This is part A, okay? 2 pi x. X is the distance always from the rectangle to the y-axis. This distance is x times f of x, the height of this rectangle, which is y. The height of the rectangle is y. This point has coordinates x, y. So its x coordinate will give you this distance from the point to the y-axis, and the y coordinate will give you this distance from the point to the x-axis. So what is the height of this rectangle? It's y, which is cosine x square. So this will give you the volume. To evaluate this, you will solve this rectangle by substitution. You will let u equals x squared, and then du would be 2x times dx. And if x is 0, you change the values. If x is 0, you put 0 here. U would be 0 squared, so u is also 0. And if x is square root of pi over 2, then u would be the square of this, which is pi over 2. So this integral would be transformed to from 0 to pi over 2, and 2x dx would be du. Pi is a constant, you can take it outside, and I'll have cosine u. So it's integral cosine u du. The integral of cosine is sine from 0 to pi over 2. So sine pi over 2 is 1. Okay, sine pi over 2 is just 1. Minus sine 0. Sine 0 is 0. So the answer is pi. So the answer of this integral is pi. Here we need to rotate this region about the x-axis. To solve using cylindrical shells, I draw a rectangle parallel to the x-axis. The width of this rectangle would be delta y. So the integral would be with respect to y. Now y runs from 0 to 1. Okay. And now 2 pi times the radius of the cylindrical shell. Okay. When you rotate this cylinder about the y-axis, okay, this would be the radius. And this radius is just the y coordinate of this point, xy, okay? So it's the y coordinate, so it's y. The distance is y. The radius of the cylindrical shell is y times now the length of the cylindrical shell. Well, the length is this curve, the line, minus this curve. Okay, this distance, how to find this distance? This one minus this one. So the curve here, which is the line, y equals to 2 minus x. I need to solve it for x because I need everything in terms of y. So x, if you take x to the other side, x would be equal to 2 minus y. So I have 2 minus y minus the other curve, but solve it for x. Square root of x is y, so x would be y squared. So minus y squared, and this is the volume would be given by this integral. This integral is easy to evaluate. You expand y times 2 times y, and then you find the integral. Set up but do not evaluate an integral for the volume of the solid by rotating about the specified line. So here about the y-axis. Let us start by graphing the region. Y equals ln x. This is the graph of y equals ln x. This is 1. Y equals 0. This is the line y equals 0. X equals 2. This is the line x equals 2. So this is the region. Okay. We need to rotate this region about the y-axis. I will use cylindrical shells. To use cylindrical shells, I draw a rectangle which is parallel to the axis of rotation. The width of this rectangle would be dx. X runs from 1 to 2. Now the method 2 pi times x, the radius of the shell. The radius of the shell is the distance from here to here. This distance is x because this point has coordinates xy. So this is the radius of the shell. So the radius is x, 2 pi x, times the height of the shell. The height of the rectangle, sorry. The height of the rectangle is this curve minus 0. So this curve is what? It is y equals ln x. So lnx. So this will give you the volume. Notice that you can solve this using the previous method, the first method, which is disk and washers. Okay, but let me remind you with the formulas of disk and washers. So using disk and washers, if we are rotating about y-axis, we will choose a rectangle perpendicular to the y-axis. So perpendicular to the y-axis, this is the y-axis, perpendicular to the y-axis. So the width of the rectangle would be delta y. So the volume would be integral of from C to D pi times outer radius square minus inner radius square. That's the formula. If it is one radius, there is no outer and inner, so it would be pi times outer radius times the radius square. That's it. Okay. So here outer radius will be a function of y and inner radius would be a function of y. While about x-axis, the integral would be with respect to x, and it would be from a to b pi times the outer radius, which is f of x squared, minus the inner radius, which is g of x squared in this case. So notice that with disk and washer, y about y-axis with respect to y, about x-axis with respect to x, while when we use cylindrical shells, it is the opposite. About y-axis x, about x-axis y. All right. So let us try to solve this example or this question using disk and washer. So the same, okay, the same curve. Here I need to know this point, okay? This is y equals ln x. So this point would be ln 2. Okay, so this point is 2 and ln 2. So the y here is ln 2. About y-axis, I'll choose uh, a horizontal rectangle. Let us say horizontal rectangle dy. So the volume would be with respect to y. All right. Now the formula y from where to where? Here from 0 to ln2. Okay. Now pi times. Okay, we have pi times the outer radius square. Where is the outer radius? The distance from the axis of rotation to this curve. Well, this is a straight line, vertical line, x equals to 2. So this distance is always fixed, which is 2. So here, 2 square, okay, 2 to the power 2. This is the outer radius square, minus the inner radius. The inner radius is the distance from this point to this curve, okay? This is the inner radius. Well, this curve is y equals ln x. And this distance is x. Okay, this distance is the x coordinate of this point. So I need to write x in terms of y. Well, y equals ln x if and only if x equals e to the power y. If you change from logarithmic to exponential. So actually, this x is e to the power y. So the inner radius is e to the power y all to the power 2, and this would be the volume, okay? Of course, this is e to the power 2y, this is 4, so it's 4 minus e to the power 2y times pi. And please check in the calculator that this integral and this integral, these two will give you the same answer. Of course, this integral here is easier than this. We can solve this integral by substitution. But here x times ln x, we don't have yet the tools to find this integral. Okay, y equals x cubed and y equals 8 and x equals 0. So this region, this is the region. About the x-axis, well, I choose, using the cylindrical shell, I choose a rectangle parallel to the x-axis. So the volume would be given by the integral would be with respect to y, because the width of the rectangle is dy, and then 2 pi times the radius. The radius is the distance from this point to the axis of rotation, which is the x-axis in this case. And this distance is y. So I have y times the height of, or the length in this case, the length of the rectangle. Well, the length of the rectangle is this curve, which is x cubed, but I don't need it x cubed. I need to solve it for y. So if y equals x cubed, then x is the cube root of y. So the length of this rectangle is just the cube root of y. And y is from 0 to 8. It's okay to try to find it. Okay, let me also, so this lesson would be a review. Let us try to find the volume using now a perpendicular rectangle, a vertical rectangle perpendicular to the x-axis, the axis of rotation. All right. Here, the volume would be in terms of x, because the width of the rectangle is dx. And the formula would be pi times the outer radius minus the outer radius square minus the inner radius. Where is the outer radius? It is the distance from the axis of rotation to this curve, okay, which is y equals to 8. This distance is 8. So I write here 8 to the power 2 minus the inner radius. The inner radius is the distance from here, to this curve. Well, this is the y, okay, the y of this curve. What is the y of this curve? This curve is x cubed. So it is x cubed raised to the power 2. So 64 minus x to the power 6 dx times pi, and x here from 0 to where? I need to find the coordinates of this point, okay? So this is y equals to 8, and this is y equals x cubed. So if y is 8, then x cubed is 8, or x is cube root of 8, which is 2. So from 0 to 2, from 0 to 2. Also, please check that these two integrals will give you the same answer. Here about the line x equals to 7. This is a parabola, opens downwards because a is negative. A here is -1, b is 4, okay? So h would be negative b over 2a, that's the formula. So it would be -4 over 2 times -1, that's -2. So h is 2. k, to find k, I replace x by 2 here. So 4 times 2 is 8, minus 2 square is 4. So it is 4. So the vertex of this parabola is 2 and 4. That's the vertex. It will go down. So it will intersect the x-axis. So I need to find the x-intercepts. Well, the x-intercepts, 4x minus x squared is 0. If you take x as a common factor, then 4 minus x is 0. So the x-intercepts are 0 and 4. So 0 and 4. So this is the parabola. This is the graph of the parabola. Well, I have also the line y equals to x. So if this is 4, this is 4, 4, and 0, 0, it passes by 0, 0, and 4, 4. This is the line y equals to x. So where is the region enclosed by the parabola and the line? It is this region. Okay, we need to rotate this region about the line for, this is 4, 5, 6, 7, about the line x equals to 7. So we take a rectangle which is parallel to the axis of rotation. So the volume would be, the width of the rectangle is dx, and x is runs from 0 to this point. Okay, this point. Actually, this point is 3, and we need to find it by finding the intersection points between the line and the parabola. We can just equate the two equations. If you bring x here, I'll have 3x minus x squared equals to 0. And if you take x as a common factor, then you will find that 0 and 3 are the solutions. So 0 and 3, x0 and x3. So x runs from 0 to 3, 2 pi times the radius. Now, where is the radius? Well, the radius is the distance from here to the axis of rotation, from the rectangle to the axis of rotation. This distance is x. But this point here has coordinates xy, okay, xy, this point. And this distance is actually x, all right? This distance is x. And the distance from here to here, is 7. So I can find the red distance, which is the radius, if I subtract 7 minus small x minus this one. So 7 minus x times the height of the rectangle. The height of the rectangle would be the curve above, which is 4x minus x squared, minus the curve below, which is x. So this will give you the volume. Using the other method here is difficult because we have to use two regions. We have to divide the regions into two. And the first region, this above region, we have to solve this equation for x, solve the parabola equation for x, which is difficult. So I am not going to try it. Here, y equals square root of x, y is 0, x is 4. So this point is 4 and square root of 4, which is 2. We need to rotate about the y-axis. Using cylindrical shells, I choose a rectangle parallel to the y-axis, the axis of rotation. So The width of the rectangle is delta y, dx, sorry, as dx. So dx, delta x, change it to dx. X from 0 to 4, 2 pi. Uh, the radius is the distance from here to here, which is x, times the height of the rectangle, which is f of x, or square root of x. So this will give you the volume. I can use here disk and washer, and it would be similar to this question. Okay, it's similar to this one, so I'm not going to do it. Y equals, the rotation is still about the y-axis. Y equals x cube, y equals 0, x equals 1, x equals 2. So where is the region between all of these curves? Yeah, this region. This is y equals x cube. This is y equals 0. This is x equals 1. And this is x equals 2. So it's this region. Well, I'll choose what is the axis of rotation? It is the x-axis. So I choose a rectangle parallel to the y-axis. Sorry, the y-axis. Okay. Axis of rotation is the y-axis. Rectangle parallel to the y-axis. So del dx is the integral with respect to x. X is from 1 to 2. All right. From 1 to 2. And 2 pi times the radius is from this here to here, which is x, times the width of the rectangle, the height of the rectangle. The height of the rectangle is this curve, which is x cube minus 0, so times x cube, and that's easy. Also here, using disk and washer will give you a washer. It would be difficult than this one, but you can do it easily. Y equals 1 over x. This is the graph of y equals 1 over x. It is not like this exactly, okay? Yeah, you can make it like this. So at 1, x1 and x4, from 1 to 4. And the line y0. So this is the line y0. This is x1 equals 1. This is x equals 4. And this is the curve. So it is this region. I choose about y-axis. We are still rotating about y-axis. I choose a rectangle parallel to the y-axis. So the volume would be the integration with respect to x from 1 to 4. 2 pi. The radius is from here to the axis of rotation, which is x, because this point has coordinates xy, and this is x coordinates, times the height of the rectangle, which is y, which is equal 1 over x. So x times 1 over x is 1 here, and actually this would be from 1 to 4, 2 pi dx, and 2 pi is a constant. So the answer would be 2 pi times 4 minus 1, which is 3. So the volume would be given by 6 pi, okay? Using the shell here, washer, disk and washer, is not easy at all. We have to divide the region into 2 regions. We are still doing about the y-axis, doing the rotation about the y-axis. Y equals 4x minus x squared. I think we graphed this here. 4x minus x squared and y equals to x. Yeah, it is this one, okay? It is this one. But instead of rotating about x equals 7, he wants to rotate about the y-axis. So I'll use this information. 2, 4 is the vertex. 1, 3, 0, 3 are the intersection points. Okay. So 1, 2, 1, 2, 3, 4. This is the vertex. It goes like this and also like this. And 4, 4, this is the line. And this is the region. But now we need to rotate about the y-axis. So I choose a rectangle parallel to the y-axis. Okay. And the volume would be integral with respect to d with respect to x, because the width of the rectangle is delta x, and 2 pi times here the radius is this distance, which is x, times the height. Well, the height of this rectangle is the upper curve, which is 4x minus x squared, minus the lower curve, which is x. X runs from 0 to 3, as we have seen in the other example. So the only difference between the two questions, the radius is the radius. The radius here is x, while the radius here when we solved the question wasn't x, was 7 minus x. Okay, that's the difference between the two questions. Now we will rotate about the x-axis. So we have the graph of this one, x times y equals 1. It is y equals 1 over x. Okay, so it is this one. X equals 0, it is this curve, the y-axis. Y equals 1, let us say that this is y equals 1, and this is y equals 3. So the region is this one. Okay, we need to rotate this region about the x-axis. About the x-axis. So we choose a horizontal rectangle. And the volume would be, the width of the rectangle is dy, delta y. So the integral is with respect to y from 1 to 3, 2 pi. Now the radius, which is the distance from the rectangle to the x-axis, is y, because this point has coordinates x and y, so this distance is y. So the radius is y, times the length of the rectangle. Well, the length of the rectangle is this curve minus this curve, which is 0. Okay, uh, so this curve is what? Is y equals 1 over x. But I need it to be solved for x, not for y. So I can just write it x equals 1 over y. So actually it is 1 over y minus 0, because x here is 0. So x of this one minus x of this one, but this is x0. Or you just know that the length is the x of this curves, of this curve, the x of this curve, which is 1 over y. Again, here you can cancel y with y, and the answer would be 2y times 2. So it's 4y. That would be the volume. Again, using here disk and washer, choosing a vertical rectangle will be difficult, because we have to uh, divide the region into two regions. Y equals the square root of x. X equals 0, which is this one. And y equals 2, this one. So where is the region? This is the region. We need to rotate this region about the x-axis. So we choose a rectangle parallel to the x-axis. The width of this rectangle is dy. So the integral would be with respect to y. Y is from 0 to 2. The width 2 pi times the radius. This is the radius, which is y, times the length of the rectangle, which is the x of this point, the x of this curve. This curve is y equals the square root of x. I need its x. I need to solve it for x. X would be y squared. So this will give you the volume. Uh, Solving this using washer method is possible, but it's also more difficult because we have an outer radius and an inner radius. But you can do it. All right. Here I have this parabola. This parabola y square ay square plus by plus c opens right or left. If the coefficient of y square is negative, it opens to the left. So this parabola opens to the left. It's a horizontal parabola, not a vertical parabola. A here is negative 3. B here is 12. We start here by finding K and not H, okay, because K is connected to Y, okay. So what is K? K will have the same definition of H, but here uh, K will be found first because K is connected to Y. So negative 12 over 2 times negative 3, negative 6. So K is 2. What is H? Now I put 2 here. So negative 3 times 2 square, which is 4, plus 12 times 2 minus 9. So this is negative 12 plus 24 minus 9. The answer is 3. So the vertex is 3 and 2. 3 and 2. And it will open to the left because A is negative. So it will cross the y-axis. So there are y-intercepts. How to find the y-intercepts? We put x0. We divide by negative 3 and we solve by factoring or by quadratic formula. So 1 and 3. So this parabola will intersect y-axis at 1 and 3. X equals to 0 is this line. So the region enclosed by this parabola and x equals to 0 is this region. Now we need to rotate this region about the x-axis. So I choose a rectangle parallel to the x-axis. Notice that this curve, which is the parabola, is always to the right of the y-axis. So the volume here would be with respect to y, because the width of the rectangle is dy, and y from 1 to 3, and 2 pi times the radius. The radius is this distance, which is always y, and the length of the rectangle is the x, this x, and this x is the x of this point which lies on the parabola. So it is negative 3y squared plus 12y minus 9. So 2 pi times the radius times the height, this will give you the volume. Using washer here is not possible because we need to solve this equation for y. Okay, we need to solve it for y equals. Very difficult. Okay, here I have again parabola, horizontal parabola because y square. A is 1, B is negative 4. So I'll find K. K is negative B, so it's 4 over 2a, so it's 2, and I find h. H is 2 square, which is 4, minus 4 times 2, which is 8, plus 4, so it's 0. So 0, 2 is the vertex of this parabola. This point is the vertex of the parabola. It will open where? To the right, because A is positive. So it would open to the right. Now, what about this line? Well, I need to find the intersection points between this line and the parabola. So I will solve them together. Here from the line, I have x equals 4 minus y. And from the parabola, I have x equals this. So I put them equal to each other. So y squared minus 4y plus 4, this is the x of the parabola, equals the x of the line. This is a quadratic equation. Minus 4y plus y is minus 3y plus 4. So no, 4 cancels with 4. So there is no 4 here. All right. So I have y0 and y3. If y is 3, then x would be 4 minus 3, 1. If y is 0, then x would be 4. So 4, 0, this is one point of intersection. 1 and 3, this is another point of intersection. Well, the line, to graph the line, I need 2 points. Also, if you put x0, y would be 4, so it will pass by this point. So this is the graph of the line, okay? And the parabola will intersect here and here at this point. So the region enclosed by these two, the parabola and the line, is this one. And we need to rotate this region about the x-axis. All of these questions about the x-axis. Yes, the x-axis. All right. So we take a rectangle parallel to the x-axis. You notice here, taking a vertical rectangle will make it very difficult. And we need to solve this equation for y, for it's not possible. Here, the only method to use is the cylindrical shell. So the volume is equal to, the rectangle is horizontal, so the width is dy delta y. So the rectangle with respect to y. Y from where to where? From 0 to 3. All right. 2 pi times the radius of the cylinder. You need to imagine that you will rotate this cylinder about this curve. So this is the radius and about this line, sorry, and it is y. The length is y. The radius is y. What about the length of the rectangle? It is this curve minus this curve. Okay, so this curve, the line, I need it to be x equals, because it's x of this line minus x of this curve. So 4 minus y, okay, minus the parabola, which is y squared minus 4y plus 4. So this will give you the volume. You can here, of course, write it negative y squared plus 4y minus 4, and then you add its minus y squared. 4y minus y is 3y. 4 minus 4 would be cancelled. So it would be this integral. And then you can also multiply y inside, and you find the integral easily. So this would be the volume of this region when rotated about the x-axis. The region bounded by the given curves is rotated about the specified axis, here the y-axis. Find the volume using a. X is the variable of integration. All right. Let us start by graphing the region. X square, y equals x square, and y equals 8 square root of x. Let me find the intersection points between the two curves. So I raise it to the power 2 to get rid of the square root. So x to the power 4 would be 64x. Then x to the power 4 minus 64x is 0. Taking x as a common factor, the intersection points would be 0 and 64. X is 0 and x is 64. I'll use this one for example. If you put x 0, y would be 0. If you put x 64, square root of 64 is 8 times 8, 64. All right. X is 64. Square root of 64 is 8 times 8, 64. This is not good. X to the power 4 equals 8 times 8, 64 x. If you take x as a common factor, this is x cube. This is x cube. X cube minus 64, so x would be 4. You know how did I find the mistake? Because if you replace x here by 64, y is not 64. So this point does not satisfy both curves. So the correct answer is x is 4. And now if x is 4, square root of 4 is 2. 2 times 8 is 16. And if you put here x is 4, y would be also 16. So these are the 2 points of intersection. So 0, 0, 4 and 16. 1, 2, 3, 4. Let us say this is 16, okay? So this point is 16. Now I have x squared, so that's x squared. And 8 square root of x would be like this. So about the y-axis. So this point of intersection is 4 and 16. All right. Now about the y-axis, and we need the variable of integration x. So we need to integrate with respect to x. To integrate with respect to x, I have to take a rectangle, a vertical rectangle. So the width is delta x. If I take a vertical rectangle, it would be parallel to the axis of rotation. So I have to use cylindrical shell method. So 2 pi times x would be the radius of the shell times the height. The height would be the upper curve, which is 8 square root of x, minus the lower curve, which is x square. And this would be the solution. But x from where to where? From 0 to 4. Well, part B, I have to choose a rectangle, in this case, perpendicular to the axis of rotation, which is the y-axis. In this case, the integration would be with respect to y as needed. Y is the variable. All right. Y from 0 to 16. I have to use disk and washer now. And this is a washer. If you rotate this small rectangle about the axis, this axis, you will get a washer. So what pi times outer radius. Well, the outer radius is this distance from the axis of rotation to the outer curve. So this point is xy. This distance is the x coordinate of this point, which lies on this curve, which is y equals x squared. So I need x of this curve. Y equals x squared, so x would be square root of y. Of course, positive or negative, but we are in the first quadrant, so it should be positive. So it's the square root of y. This is the distance from here to the power 2. This is the outer radius minus the inner radius. The inner radius is this distance from here to the inner curve. This point has coordinates x, y. So this distance is the x coordinate of this point which lies on this curve. This is the curve. So I need x. I need to solve it for x. Well, y equals 8 square root of x. To solve it for x, I'll divide by 8, and then x would be y square over 64. So y square over 64, this would be the inner radius. I raise it to the power 2. Please check that these two will give you exactly the same answer. All right, y equals x cubed and y equals 4x squared about the x-axis. Let me find the intersection points. X cubed equals 4x squared. X cubed minus 4x squared is 0. X squared common factor. X minus 4 is 0. So either x is 0 or x is 4. If x is 0, y is 0. If x is 4, 4 to the power 3 is 60. 4 to the power 2 times 4 is also 64. So our answer is correct. Now, if this is 0, 0, assume that this is 4 and 64. So x cubed will go like this. And 4x squared will go like this. So they will meet here. So this curve is y equals x cubed. And this curve is y equals 4x squared. Well, you can check, you can make sure that this is correct. If, for example, you replace x by 2, then 2 to the power 3 is 8. So this is 8. While here, 2 to the power 2 is 4 times 4, 16. Okay, so 4x squared is above x cubed. But this is the region, and we need to rotate this region about the x-axis. And in the first part, we need the integral to be with respect to x. For the integral to be with respect to x, we have to choose a vertical rectangle. The width of the rectangle would be x. So the rectangle would be with respect to x. X from where to where? This point is 464. So x from 0 to 4. Which method we are using in this case? The rectangle is perpendicular to the axis of rotation. So we are using the washer method. So it's pi times the outer radius minus the inner radius. Where is the outer radius? Well, the outer radius is the distance from the axis of rotation to the outer curve, which is this curve. This is a point on this curve, 4x squared. It has coordinates xy. So the outer radius is the y of this point, which is 4x squared. So 4x squared, this is the outer radius, minus the inner radius. The inner radius is the distance from here to here. This point has coordinates xy. It lies on the curve y equals x cubed. So the inner radius is y of this curve, which is x cubed. So we raise x cubed to the power 2, and this will give you the volume with respect to x. Now, how about horizontal rectangle? Well, horizontal rectangle would be like this. it would be parallel to the x-axis. So we are going to use cylindrical shells. So dy and y from where to where? From 0 to 64. 2 pi times x, which is the radius. Okay, which is the radius. Where is the radius? From the rectangle to the axis of rotation. This is the y. Okay, this is the y, not x. This is the y times the length of this rectangle. The length is the curve to the right minus the curve to the left. The curve to the right is y equals x cubed, but we need to solve it for x, so x would be cube root of y. Now the curve to the left is y equals 4x squared. We need to solve it for x. So it would be y over 4 equals x squared, and then x would be square root of y over square root of 4, which is 2. So this will give you the volume. And please again check that these two integrals will give you the same answer. Some additional exercises about lines. Use the method of cylindrical shells. Cylindrical shells. Okay. About x equals to 3. Y equals x cubed. Y equals 8. X equals 0. So we know this region. We have seen it before. Okay. But we need to rotate this region about the line x equals to 3. This point is 2, 8. Okay. And this line is 8. Okay. So the line x equals to 3 is here. We need to rotate this region about the line x equals to 3. Using cylindrical shells, we take a vertical rectangle because it should be parallel to the axis of rotation. So what would be the volume? The volume would be delta x is the width, so the rectangle with respect to x. X from 0 to 2 pi times the width times the radius of the cylindrical shell. Imagine that this cylindrical shell, you will rotate this one about this line. Okay, so the distance from here to here is the radius. Always try to imagine this distance. Okay, so how to find this green distance from here to here? Well, I know that this distance from here to here is 3 because this is the line x equals to 3. And here, this distance is x. Okay, this distance is x. So 3 minus x would be the radius of this cylindrical shell. Also, the height. What is the height of the rectangle? The above curve is y equals 8 minus the lower curve y equals x cubed. So it's 8 minus x cubed. This would be the volume. I leave it for you, if you are interested, to try to solve it using a disk and washer, using disk and washer method. You can do it. It's not difficult. And you check yourself by checking that the two rectangles will give you the same answer. Here I have a line 4 minus 2x If I put x0, y is 4. If I put y0, 2x would be 4, or x is 2. So this is the line. This is the line. I need to draw it better than this. I hope it will be better. Okay, this is the line. Allah. All right. Where is the region? This is the region. Why? Because y equals 0 is this one, x equals 0 is the y-axis, and that's the line. We need to rotate this region about the curve of the line x equals -1. This is x equals -1. So this region is rotated about this line, and we need to use cylindrical shells. So we choose a rectangle parallel to the axis of rotation. So the volume would be integral with respect to what dx, because the width is delta x, from where to where, x from 0 to 2 pi times. Now where is the width? Well, the width is, sorry, not the width, the radius. What was the radius here? Yeah, okay. Radius. What is the radius of this cylinder? Imagine you are rotating this cylinder, this rectangle, about the axis of symmetry. Well, I know that this point is x and y. So this distance is x up to the y-axis. But this distance is 1. From x equals to -1 to the y-axis, 1. So 1 plus x would be the radius of the cylindrical shell, while the height is y of the line, which is 4 minus 2x minus y of the x-axis, which is 0. So this will give you the volume of this line. I think this is the last question. Okay, good. So this is y equals the square root of x, and x equals to 2y. I need to find their intersection points. So I'll find y from here. Y from here is x over 2. So square root of x is equal to x over 2 uh, raised to the power 2. Square both sides. Multiply by 4. So 4x minus x squared is 0. Take x as a common factor. So either x is 0 or x is 4. If x is 0, y would be 0. If x is 4, square root of 4 is 2. Also, if x is 4 here, 4 over 2 is 2. So 4, 2, this is a point of intersection. So this is the square root. And this is a straight line, x equals to 2y. Okay. Excuse my graph. I'll do it again. So yeah, to make the region clear, this is the point 4 and 2, and this is the region we need to rotate about what? About the line x equals 5. So this is 4, this is 5, so this is the line x equals 5. Rotate this region about the line. So what is the volume? Well, we need to choose a rectangle parallel. So dx integral from x from where to where? From 0 to 4. 2 pi times the radius of the cylinder. Imagine that this cylinder will be rotated about this curve, okay, about the axis of rotation. So the this line represents the radius of the cylindrical shell. So how to find the distance? Well, I mean how to find the length of this line segment. This one is 5 and this one is x, because this point has coordinates x, y, and that's the x coordinates. So what is the radius in this case? 5 minus x times the height of the rectangle, which is the above curve square root of x minus the lower curve. I need to solve it for y. X over 2 already solved. We solved it before. So this will give you the volume. And again, homework for you after this time with volume disk and washer and volume by cylindrical shells, you should be able to find the volume using shells here. Thank you very much and have a nice time.